Populations. The majority of this unit is going to be about human population. I will talk about other animals and organisms, but it's the majority of human. When we go to the next unit, which is biomes, we're going to talk about organisms, because we're going to talk about all the organisms in the world, and we'll bring back a little bit of populations and evolution. I left this out of the last unit, so we're going to start with species within the population, which is kind of what we talked about last time. But these two categories of strategists, I'll call them that, like R and K, we did not talk about in the last unit, so I want to talk about it now. Their characteristics are what define them. But there could be a middle. So you can show some characteristics of R and some characteristics of K, and you'll fall somewhere in between R and K, or you could be all R and all K. So for starters, R strategists are weak and K are strong. R strategist size, small. K strategist size, big. They're calling me? This is terrible. All right, R strategists, they mature they mature early, okay? And because they mature early, they end up having a lot of offspring. And because they have a lot of offspring, they rarely care for their young. So their lifespan is relatively short. I did that because so we could just get through it, because we're already behind. K is the complete opposite. We are K. Let's say females generally cannot reproduce for 13 years versus a cockroach can reproduce when? Practically at birth, right? We live hopefully long lives. We have few offspring every time we give birth. You don't have multiple births or multiple babies at birth, and we care for our young. We are the extreme K, and I would say a cockroach could be an extreme R. And in the middle, you could have some variation. Like I'll use a dog as an example. A dog can have a large litter, can reproduce after a year of birth. After being born, in a year, they can have babies. But they care for their young. So they're kind of somewhere in between. So you're not always extreme R or extreme K. Now, what is the definition of a population? A group of species in a given area at the same time. And it's a group of the same species. You don't want to confuse that with community. Community is different species. Okay? If we're going to calculate populations, what are we going to factor? What are things you factor when you calculate populations? Because this entire unit is about formulas, calculations, and factors that influence those calculations. So, number of a specific organism in a given place. That's definitely a factor. What else? Sure. Yes. We're going to look at that. What else? Resources definitely is going to be a factor that influences populations. What else? Births, for sure. Okay, so all of these things we're going to talk about for formulas, and we're also going to talk about what influences each of those things. So the first thing we calculate is size. As you said, the first thing you want to see is how many people are in a given area at a given time. That's population size, and that is how you calculate size. But if we calculate density, what are we looking at? So you're going to calculate the same thing. You're going to calculate size, but you're going to calculate it per unit area. So if we took the population size of period C, in this room, we're 33 people, in this room, right? Every period C. If I take period C and I try to teach in my office, how would we feel? Cramped. The resources would not be enough to meet the needs of every single person in this class. So if you look at density, like I'll look at Texas, size versus density. They're in terms of size, it seems like they are high on the population curve, but in terms of density, they're not. They're relatively low because the state is so big. Then you look at small state, like right here, size, relatively average, but they are densely populated because the state is smaller. Does that make sense? Okay. Dispersion. What are we looking at if we're calculating population? The way they're what? What? Give me another word for dispersed. Distributed, grouped, arranged. I like the word group because it definitely characterizes one of the arrangements, okay? So what do you think the arrangements are? And there's three, generally. Equally distributed, what they call even or uniform or equal. You could put all those words because they all mean the same thing. What else? Grouped is actually clumped, but I like the word grouped. You could put / grouped because it totally describes the clumping of arrangements. What else? Random. Which do you think is the most common? I got that last class too. Why clumped? It's actually clumped. There are some factors that influence why most organisms. Now you think random, you think of grass and trees and, right? Because seeds, they get dispersed that way. But let's think of K, clumped, why? Resource availability is number one. Organisms go to where resources are available. Facts. Life for human population started near oceans because that's where we got our food, right? Organisms do the same thing. Where there's water is where life begins. What else? Care for their young. Huh? They can't travel. They travel in groups because, why? Protection. Good. Where there's a group, what do they have an opportunity for? Reproduction. Because when they're isolated, you can't have that. And the last thing, you keep saying the word group, okay? Together, when you work in your group, what do you get done? You get done more things. You work together to get things done. They work together to get things done. And I will show you today the best video that describes caring for young, protection, resource availability, and group work. Best video. I'll keep you hanging for a little while. All right. Populations obviously can grow, shrink, or remain the same. What are the 4 factors that influence that growth or the lack of? Those are factors that would influence this. But what are the 4 main? This is formula number 1, I'm going to call it. What are the 4 things that we're going to, not formula, but the 4 factors that will give us formula number 1? What do we have to calculate if we're calculating growth? Birth. What else? Death. Migration. In or out? M-A? In, M-E, out. Emigration for exiting. Immigration for in. If you write that down, you'll remember. Okay? Now, this is formula number 1. And I told period A, write formula number 1. Because that way you remember how many formulas you need to know. They're easy. So don't start, oh my God, I have to learn formulas. They're easy formulas. You have to apply the formulas. That's the hard part. The learning of the formula is easy. So how do we calculate growth? Birth plus, whoops. Correct. I gave it all away. So that's formula number 1. Formula number 2, which a lot of people miss because they jump into formula number 1, is natural growth. If we're calculating natural growth, what are we eliminating from the formula? migration, period. In or out. So we're only calculating? Correct. This is how most birth rates or death rates or growth rates are calculated. They're calculated with formula number 3, which is the crude rate. So formula number 3 describes crude birth rates or crude death rates or crude growth rates, which I didn't even put on here. And what you're calculating is the number, if we're calculating crude birth rates, we're calculating the number of births divided by the total population times 1,000. If you're calculating crude death rates, you're calculating the number of deaths divided by the total population times 1,000. Growth rate, same thing, okay? Most times on the AP exam, if they're going to give you calculate this, you'll see numbers and you don't recognize the numbers. It's because it's the rate. And this is the type of information that will be given. I'm not going to do any calculations until Monday. Okay? We're going in for notes. We'll do calculations. If you have an opportunity to learn the formula, then we'll do the calculations. Okay? But they'll give you a year. They'll give you the total population. And then they'll ask you, calculate the crude birth rate. Okay? Things like that. All right. Formula number 4. Is called the rule of 70. The rule of 70 is a way to calculate how long it'll take a population to double. Or you could calculate the rate that it'll take. Okay? It is used, I'll give you a better example for finances. So if you have money in the bank, and you have a savings account, you want to know how long will it take your savings account to double, they have to give you the rate for you to use this formula. And if you use the rule of 70, it works. It's the same as those logs that you do with your amazing math teachers. I could give you this rule and you don't have to do the logs and you get the same number every time. So I'm going to show you, doubling time is going to be referenced as T. The rate is R. You have to write this down. You have to remember. Never convert the rate into a number. The rate is given to you as a percent, so 1.7%. That's the number you plug into the formula. You do not convert that 1.7 into an actual number like 0.017. You use 1.7. It's a strange factor, but that's the way the formula works. This is the type of information that will be given to you, and again, we'll use the information and use the formula to calculate a couple of examples. But they'll give you a year, maybe. They'll give you a rate, maybe. Or they'll give you a doubling time. If they give you the doubling time, so they give you T, it would be 70 over T. If they give you the rate, it's 70 over the rate. It's the same formula always. Okay? We'll work on that next class. And I give you 2 examples. And by the way, sometimes the formula is a 2-step question. Tell me the doubling time and then tell me what year the population will be this much. And then you have to figure out the year, okay? We'll work on those. All right, what is a fertility rate? Fill in the formula for me. The definition. A number of births a woman will have in her lifetime. Total fertility rate. Which makes no sense at all, right? The word total should be there. But guess what word is there? Average. Why? Why don't they call it the average fertility rate? So underline the word total and draw a line to the word average, because this is the type of definition that the AP exam used to love to give. I don't know if they're still into that, more applying it now. But we look at the average number of children a woman has in her lifetime, and obviously during reproductive years, because you can't give birth any other time except those. But they mean in a specific age group, and they consider reproductive years age 14 to 35, even though now it's more like 27 to 48. I mean, the shift in reproductive years is huge. And this is what I mean by the difference of calculating, because so many factors influence birth rates, death rates, and growth rates. All right, I am done for today.